Hello everybody, welcome to my channel. Today we have a very good problem for you guys called permutation and strength. So this is a very good one. So I highly encourage you to pay close attention to the problem statement, right? So it said we're given two string S1 and S2, return true if S2 contains a permutation of S1, right? Or we can return false otherwise. Okay, so it says in other words, return true if one of S1 permutations is the substring of S2. Okay, so here's a very concise, simple problem statement, right? So as you can see, right, we have this particular example, right? So we're giving them those two strings, right? And our job is to find out is S1 present in S2, right? So S1 present in S2, okay, pretty simple. I can think of, right? Okay, so I check, okay, return true. I'm looking at it, I don't see any AB, right? I see a BA. Yeah, but BA is a valid answer because they're not only asking to find if S1, right, this particular substring, this particular string, right, is present in there, right? They're asking, if the substring present, also any of the permutations, right? So permutation is pretty much a different arrangement of the letters, right, in this particular case, right? So AB and also BA, right? BA is a permutation of AB, right? So it's a different arrangement of the characters, right? It's kind of how you need to view it, right? So BA is present. That's why BA is a valid answer. We return true for those particular cases, right? And we have AB. There's no AB here. We have BOA, which is as close as you can get, right? But it's not a substring, guys, right? We have this O in between, which really prevents us to get a match, right? If there was an O in there, right? ABO, right? This would have been a valid case, right? If S1 was ABO, this would have been a valid case and return true, but since O is present here and there's no O in this one, therefore it uh, doesn't match, right? It doesn't count as an answer. Okay, so how can we go ahead and solve this particular problem, guys? Right, so we could solve this pretty good way, guys. Right, so what I'm thinking, what we could do is to pretty much start the most obvious way answer how we do things, right? We have AB, so we go ahead and do a double for loop, right? For each, so we keep checking, right, for all the substring of length of S1, right? Okay, all substring of length is S1. We look, does it equal AB, right? We check the first set of two, right? And then we check the next set of two. Nope, equal, next set of two, nope. Next set of two, nope, does not equal AB, right? And we keep going about it. You see that we skip our answer there, right? Which is not good, right? Okay, so doing it naively like that, AB, does a string equal this string, right? It's not going to be sufficient. What we're going to have to do, it looks like, right? We need to also account for the different permutations, right? Okay, so let's focus on this idea, right? So of, permutations, right? So, permutations are a different arrangement of the characters, right? So a permutation of AB, I can think of is only BA, right? It's the only other one that can be, generated, right? So we need to find out, right? So for every substring of length 2, right? Does it equal to this one of the permutations, right? So for this case, yeah, so we go ahead, boom, does it equal to AB or BA? Nope. Does it equal, we keep doing that until we find that, then we'll return that, right? So as you guys can see, this could work for very small test cases, right? But when we have to deal with, like, for example, right, um 10,000 characters, right? It really becomes very, very big, right? So to generate all possible permutations, right, cost us 10,000, right? So for this particular case, right? So so if you have a string, right, and you want to generate all possible permutation, right, it would cost us n factorial, right? So as we get to very big numbers, this would not be good, guys, right? You can see the time complexity is very, very bad, right? It's one of the worst time complexities you can pretty much have, right, for any solution, right? Right? But we have to do a little bit better, right? Because this will most likely not be accepted in every setting, right? But it's good though to start, thinking in that mindset, right? So you can kind of understand how we can go about it, right? Okay. So this permutation idea that I just brought up, right? Different arrangement of the characters, right? It should kind of ring a bell a little bit, right? So permutation, uh, permutation, different arrangement of characters, right? So we've done a problem similar to that, right? Which we chalked what's called anagrams, right? Pretty much anagram, right? So two strings, string is an anagram of another string, right? If I anagram of a string, right? So if the two, if two things are met, right? They're the same length, right? And the frequency of the characters are also matching the same, right? So if in one string I have one A and and if in one string I have one A and one B, in the other string I can have one A and one B as well, right? As long, yeah, exactly. It has to be exactly one A and exactly one B, right? The frequency of the characters, they have to also match, right? So it's with that idea, right? We're gonna expand on that. We're gonna use those techniques that we've used, right? Right? Because this other problem that we did, right? We were tasked to pretty much check if two strings are anagrams of each other, right? And what we ended up doing, right? We make sure that they were the same length, right? And not only that, right? We started counting the frequency of the characters in both strings, right? And then we compared the frequency count, right, to check if there's any mismatch. If there's any mismatch, that means that there must be it must not be valid, right? So let me kind of help you guys understand it real quick. All right, so let's say we're given the frequency map is like that, right? So a frequency array of size 26 to represent the 26 letters in the alphabet, right? So we go ahead and populate with zeros, right? A bunch of zeros initially, all the way up to the last one, right? So I'm gonna create the index for you guys so you guys can kind of visually see it. Okay, only represents the 26 characters in the alphabet, right? So for example, right, so say we wanted to create, right, the frequency count for AB, right? So we would count it. We would be one. There's one A, right? Zero is index one. A is index one, zero, right? And then B is index one, right? So we would capture that, right? Boom. We have our frequency map, which represents the frequencies of each of the characters and the string. Right? So now that we have that, right, we could get another string, right? Say we was BA, right? We do the same thing, right? We initialize to zero, right? And we're like, okay, cool. We create a frequency graph. There's one B, we increment the count one. There's one A, we increment one, right? And then we could see, right? We can compare two of those maps, right? If they are the same, then we can say those two strings are anagrams of one another, right? This is a very, very simple case, but it just to illustrate the mindset, right? So by comparing those maps, right, we can say two strings are easily, right? So this is the same idea that we're gonna utilize for this particular problem, right? The same idea that we're gonna use a particular problem, right? So what we're gonna end up doing, guys, right? So we have A, B, and B, A, right? So right, so now what we're gonna do is to pretty much, right, for each of so so now we're gonna use that to help us, right? So what we're gonna do is to iterate through the string, right? So we will start off, create our frequency map of the pattern that we're trying to match, right? So we create the frequency map. We have this map right now generated, right? Cool. It says that we have one A, we have one B. That's good, right? So now we need to go through this particular string, right? All right. And now what we're gonna end up doing as we're going through the string, right, is to for each substring, right, of substring of length of the same length, right? Because it has to be the same length, obviously. Because if they're not the same length, we already know they're not anagrams, right? Because it needs to be the exact same length, right? And those characters that are present in that string has to be the same at the same frequencies as well, right? As the right. So we have AB, right? See what we're targeting, right? That's our target, and we're go and create for each yeah, now that we have that particular string, right? So what I'm gonna be doing, guys, right, to make it easy for us to follow through, for the frequency map, right, we'll use a key value, right, to make sure that it's a lot easier to update, right, and to go through this particular illustration, right. That'll be similar as we were doing, like using an array to keep track of the frequency. We did the same thing, right? Okay. Okay, so pretty much this tells us right on the map, right? In this particular string, right? We have one A, we have one B, right? Okay, cool. So now what we'll have to do now is to iterate through the string, right? And as we're going, and so what we need to do is compare every substring of this particular length, right? This is the target string that we want to match, right? Permutation of, right? All right. So what we're gonna have to do, right, is to for each substring that we're comparing, right? So we have this EI, right? This first set of string, we see there's one I, one E, and one I, right? And we checking, does this equal to this particular one, right? It doesn't, right? So therefore, we go ahead and keep on checking the next set of two, right? Then we recalculated it, right? So it'll be some sort of like a couple of folders, right? So loop to iterate through, right? And for each of that, right, we would, calculate the frequency, right? We calculate the frequency map, right? For that particular substring, right? Of that particular length of this, of the pattern's length, right? Because that's the target one, right? So we have that, we would check EI, then we would, start over again, right? Once we see the first two don't match, we move on to the next set of two, right? And we recalculate it, right? And we have this I, right? Yeah. So we have this, I, there's one, right? And then there's one D as well, right? Okay. So we'll keep doing that, until we get up to here, compare this string with like, there's one B, there's one A, right? And we check, does it equal to this map, right? It does equal to that map. So it means that it must be, right? It must be an anagram, right? Or permutation of that, right? So we have found a match, right? Which satisfies the requirement, right? Of finding a permutation of S1 instead of S2, right? So we will return true right away, guys, right? So as we can see, we're doing a lot better than previously, right? Obviously, this is a lot better, right? But we're doing a bunch of repeated work, guys, right? Because the way I was saying it, right? I check the first two, right? Then I move on to the next one, right? Recalculating each time, right? Creating a frequency map for that particular string, right? So it would not be too efficient, right? Because we have the length of left m, right? And then let's say the small string is n, right? We're doing m times n work, right? So it's not efficient at all because for each character in this big string, right? I am doing another linear thing, right? To calculate the frequency map of that particular substring that I'm referencing, right? Not very good. So as you saw that I was doing, right, I was doing EI, then I went to ID, right? So you see, we're pretty much doing some sort of removing characters from our left and adding characters from our right, right? And what technique does that usually bring to mind, right? When we see we're doing stuff just similar to this one, right? It tells that we're using some sort of a sliding window, right? The particular problem is a static sliding window, right? So how this can be useful for us, right? Is to, how about we, as we're creating the state, right? We're creating the map, right? We have this map, right? Instead of recalculating, right? How about we shrink the frequency count of whatever character that I'm referencing on the left, right? I decrement the count, and then, right, that way, right, whatever's in the middle, right, doesn't change, it stays the same, right? Okay. This particular case, there was two characters, right? But it could have been like, like this character long, right? And then I only need, so for the next iteration of thing I would need to compare, right? I would just need to remove this E, right? And just add this other thing to my substring, right? All right, instead of redoing the work over and over, I just can remove stuff on my left and add stuff on my right, which is exactly what this sliding window technique is for, right? So, and then I maintain the state, right? And at any given time, I can know exactly the amount of the frequency of all the characters that I have, right? Instead of recomputing every time, we're just updating our current state, right? This is how the sliding window is very, very useful for those kind of particular things that we do, right? So it's kind of the main takeaway, guys, right? We do a sliding window, right? We shrink from our left to our right, right? As we're, expanding, right? We make sure that the map stays up to date, right? We update the map, we increment the frequency of the character that we're adding, and whichever character that we're leaving behind, right? We remove that from our thing, right? So I think the code will make a lot more sense to you guys. So let's quickly get into the code. I think it'll be very, very fun, right? So let's see what it's all about. Okay. So we ended up saying that we'll be needing a let me make it bigger for you guys so it's like very visible. So we said that we'll create a some sort of so let's get the length first, right? So So let's do n is equal to s1 that length, right? M is equal to s2 that length, right? So we're capturing those length here. And what's next for us now, right, is to create the map, right? So let's create a target view int of size 26, right? And then we create a window, right? So pretty much this thing will help us to keep track of the frequency of the characters in our current window, right? So we can easily compare it with the target one that we have. We do that particular check, right? And yeah, and then we can know easily, does this, do they have the same frequencies, right? The characters of frequency, is it the same, right? Okay. Okay, so what we're gonna do is to go ahead and populate our maps, right? Start, right away. Okay, so what I'm thinking we need to do is to just similar how we did the other problem, which involved this one, right? So is less than n I plus plus, right? Okay, so our target, we would we'll create that, right? So what we need to do is S1. So this is our target, right? This is the one that we want to match, right? So S1, that char at that particular character, right? What's going on here? I, right, minus the ASCII value, right? So we're doing the ASCII value subtraction so that we can get the index, right, of that particular character area. So when you do subtraction, we get an integer value, right, which maps to exactly the indexation map, right? So if S1, right, so to say we're A, right, A minus A gives you 0, and then we know exactly which index to increment, right? So that's kind of what I'm doing here, okay? And then we end up doing the same thing for the windows, right? For our current window, right? Just getting it ready for us, okay? So it's this one, it should be keeping track of S2, right? So we just start building it right away, or, we increment the count, right? So now I've taken care of this one and I've taken care of that one, right? Right? Because we decided to loop through all the way to, the first set of, two characters, right? In both strings, right? Okay. So now that we have that, right, we would do a check, right? Compare we could write a function that can compare both maps, right? If there's any mismatch, or we could just use this particular thing, right? Utility functions, right? To compare two arrays, right? Two maps, right? So target and the current window, right? Maps, right? All they the same? Yeah, return true right away, right? Or we need to keep going, right? Okay. So what's next for us now is to loop through, right? We have right and left, and right, left, right. So the left corner is to help to shrink. The right corner is going to help us to expand, right? So pretty similar stuff that we've done in the other problems on this particular channel, guys, right? So we're going to start off at n, right? And then we're going to go all the way up to m, right, which is S2's length, right? Length of the bigger string. Okay? And what we're going to end up doing, guys, right? We're going to pretty much increment, right? So exactly what we're doing here, right? So this is our current window, right? Pretty much we're maintaining state, right? So the right per helps us to expand, right? So we check the first one, right? Which like it does not equal, right? So all right, we go on to the next one, right? And the next one that we're comparing, right? Is this one, right? Okay. Okay, so we compared those first two, and then we compared this one, I believe, right? Yeah, this one. Yeah, so we do this one. We're almost there. So now we said that the left corner is going to help us to shrink, right? So since we're adding one more, right, we need to remove whatever character that we have right on the left side, right? So to remove it, we decrement the count for whichever character the left corner is pointing at, right? Okay. Then we do the same check here, right? After doing that, is this particular substring, right? Okay. We've updated the state, right? We added and we remove, right? to keep it the same length. Okay. And then we check does it equal to, so those like all the maps, are they matching, right? You know, you see the target thing doesn't stays the same, right? Because that's our target map that we want to match, right? And then we have a current window, right? Which is, you know, if it gets updated every time as well, right? At each iteration, because the window that we're referencing changes. Okay. If it equals now, we return true. If not, then we also make sure to increment the left corner, right? You know, that's very important, right? So it doesn't stays the same, right? So we can remove the right character every time. Okay. So if that never hits, right, we return false. Otherwise, it's press okay. We looks good so far, right? So we need to also enter the end of the case where we have a character m, right? So n is greater than m, right? You know, so the smallest, right, the pattern that we're looking for, right, is bigger than the length of the characters, bigger than the second string, right? Which is, in that case, we can return false, guys, right away, because, you know, how am I going to find the sub like a string that's bigger than this string, right? So it doesn't match, right? So, okay, let's press submit. It was good to me. Looks like we've passed all the test cases, guys. So if you guys enjoyed the video, you guys understood the thought process in the comment section. If you're new here, subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching. I'll see you guys in the next video.